Welcome to the last section of Chapter 6, our last conic section out of the 4, and this one is called Parabolas. You should have seen at some point so far parabolas, probably in multiple classes. Okay, so we're going to take a little bit further with this one. So the objective is to find equations and to sketch the graphs of parabolas. So we have an example here on the right. This is a parabola that actually opens up to the right. And notice we still have a focus and we still have a vertex, things like that. So. Alright, so a couple things we need to briefly talk about first. A couple of vocabulary terms. So let's say I have a parabola that opens upwards. Okay, every parabola has this point down at the bottom that is called the vertex. Okay, the vertex is kind of like the starting point of the parabola. Alright. Also, parabolas have something that we call this imaginary line that goes right through the middle of the parabola, and you should have seen this before, and this is called the axis of symmetry. Okay, that line where you can cut the parabola right in half is called the axis of symmetry. Alright, so notice also that some parabolas have x-intercepts. Okay, we're not going to talk a lot about that right now, but you should notice it. It also has a y-intercept. All right, and I think that's all I want to talk about on this slide. We'll get to more in-depth things about parabolas on the next few. Okay, so there are 4 types of parabolas. On this page and the next page, you'll see the differences. Okay, I've put the equations in the top right corners. Okay, the first 2 equations that we're going to talk about y equals a positive number. So y equals positive 1 over 4p, and then y equals negative 1 over 4p. Okay, so the only difference between these 2 is the direction that they open. Okay, so this one is going to open up. I don't know why this isn't working. Oh, there we go. So this one is going to open up. Okay, and the y equals negative parabola opens down. So that should make sense. The positive version of y equals opens up because up is positive, and the negative version of y equals opens down. Okay, now notice that the vertex in both of these, okay, so we're going to talk about the vertex, is at 0, 0. Okay, so for both of these, the vertex, all 4 of these, the vertex will be 0, 0. Okay, now, each parabola has a focus point still, and it's still a little c. And if you notice that the focus is going to always be on the inside of the parabola, so no matter where your parabola is, the focus is on the inside of the shape. Okay? And then lastly, all parabolas have this point, or this imaginary line again, and it's called the, let me just put them in there. And this one would be about right here. And I'll tell you why in a second. These are called directrix line. Okay, they're called the directrix line. Okay, it's a line that is perpendicular to the parabola. All right. So how do I figure out some things about these parabolas? All right. The distance, okay, this is the important part here. The distance from the focus to the vertex and the directrix line to the vertex is the exact same distance. Okay, so the distance between the vertex, remember the vertex is at 0, 0. The distance between the focus and the vertex and the directrix and the vertex is always going to be the same for all of these parabolas. And this distance is going to be your p-value. Okay, so this distance here is going to be p. And where do we get p from? The p comes right from the equations. Okay, so I'll show you how to do that in a second. I just want to get these vocabulary terms out of the way. So y equals positive opens up. y equals a negative number opens down, and then onward to our next two. So now we have an x equals a positive and x equals a negative. So here are our right and left parabolas. So the one on the left, x equals positive, should open up towards the positive x side. And the x equals negative should open up towards the negative x side. Once again, our vertex is at 0, 0. Notice our vertex is at 0, 0. Okay, let's put in our focus point. Remember, focus is C, and it's always on the inside of the parabola. Okay, and then we also, once again, now have directrix lines. And remember, the distance has to be the same away. And I'm going to get that as close as I can. And now they're vertical because remember, they have to be perpendicular to the parabola. Okay, so there's our directrix lines. Now remember that the distance here has to be exactly the same distance. That little tick mark means that they're the same distance away. And remember, what is that distance? That distance is P. Okay, and we'll talk more about P in a second. All right, now, each of these directrix lines, each of these green lines I've drawn in have an equation. And you have to remember what the equation is. Okay, so the equation for this one will be x equals negative P, because it's down below. This one will be x equals a positive P. Okay, these, oops, sorry, that is a mistake. These should be y equals, not x equals. So let me put that in here. So this one is y equals a positive P, and this one is y equals a negative P. Remember, horizontal lines start with y equals. The two vertical ones are going to be x equals a negative positive P, and this one will be x equals a negative P. Okay, so we're going to just dive right into an example and make sure we understand how to do these. All right, so what it says is find the focus and the directrix of the following parabola. Okay, so notice, this is y equals a positive number. So I'm going to, let me put in a graph here. All right, so we know it's y equals a positive. So let's go back here. Y equals a positive is a parabola that opens up. Okay, so I'm going to draw a parabola that opens up from 0, 0, because that's what our vertex is right now. Okay, so there's my parabola that opens up. Now, we need to figure out what our P value is. That's the important part. So here is the equation that we're going to compare it to. Okay, so this is the equation I got right from the upper left corner of the screen. So the y equals positive, this is the equation that I'm using. All right, so now the important things we have to compare are the 1 over 4p with the 2, because those are the numbers that we can compare. So I'm going to set 2 equal to 1 over 4p, and I'm going to put 2 over 1. And then we're going to figure out what p is. I'm going to cross multiply. 1 times 1 is 1. 2 times 4p is 8p. And then we're going to solve for p. Divide by 8, divide by 8. P is equal to 1/8. Okay, so that's our important number. So that tells us how far the focuses and the directrix line are from the vertex. Okay, so this is going to be kind of hard because it's only 1/8. So I'm going to put this real close here. Okay, so there's our focus point. Okay, so this point right here, let me draw an arrow, is our focus. And that is C. And what is the ordered pair there? It's just up 1/8. So 0, 1/8. Okay, so there's our focus. Now, our directrix line is an imaginary line, so I'm going to draw a dotted line here, right through that dot. And all we need now is an equation for it. So it's a horizontal line, so it's y equals. And then where is it? We went down 1/8, so it's at negative 1/8. And you can get those equations right from our pictures again. So remember, y equals a negative whatever your p is. Okay, so hopefully you see that this 1/8 and this 1/8 are the same distance from our vertex, which is at 0. Okay, so that's all you got to do. It's just find the focus, which we've done right here. And it's just find the directrix, which we've done right there. All right, so example 2. It says, find the focus and the directrix of the following parabola. So this one is an x equals a positive number. So this one's x equals positive. So let's draw our graph real quick here. X equals a positive is a parabola that opens to the right. So I'm going to draw a parabola that opens to the right. All right, there it is. Now let's solve for our p. 1 over 20, and we're going to compare it with 1 over 4p. So let's cross multiply. So 1 times 20 is 20. 1 times 4p is 4p. And we're going to divide by 4. Divide by 4. What's p equal to? P is equal to 5. All right, so that's how far our focus and our directrix are from our vertex, 5. Okay, so our focus is going to be inside the parabola, 1, 2, 3, 4, 5. So there is our focus. What is our ordered pair there? It's 5 to the right, so 5, 0. And then our directrix is going to be 5 to the left. 1, 2, 3, 4, 5. Horizontal or vertical line this time. And we just need to write the equation. Vertical lines are x. So x equals what number are we at? We're at negative 5. Oops. Let me get rid of, oops. Alright, so x equals negative 5 is our directrix. There we have it. We have our directrix, we have our focus. Alright, let's go to our very last example here. This one's a little bit harder. But the same general principle applies here. Okay, let's look at the left-hand side. It's x on the left equals a negative 1/2. So this is x equals a negative. Okay, now, the problem is we have a number that's attached to x and we have a number attached to y. Hopefully you can recognize, which is the same as circles, ellipses, and hyperbolas, that we now have a different vertex. X is -1, so my vertex is 1 for x, and positive 2 will make it a negative 2 for y. Okay, so that's what I'm going to plot on my screen. Okay, now what direction? Okay, the last thing we need to think about, so we know the vertex, now we need to know the directions. X equals a negative. Where is that going to open? X equals negative opens to the left. Okay, now it's going to open to the left from our vertex. So I'm going to plot the vertex first. Okay, so 1, negative 2. Okay, so there's my vertex. I'm now going to draw a parabola that opens to the left. Okay, so there we have it. Now, our focus, we need to find our p-value. Okay, we're still going to compare our number in front. Okay, so negative 1/2. We're going to compare that with negative 1 over 4p. Now, you always compare it with 1 over 4p. If the number's a negative, you use a negative. If it's a positive, you use a positive. Okay, so let's cross multiply. Negative 1 times 2 is negative 2. Negative 1 times 4p is negative 4p. Okay, divide by negative 4, divide by negative 4. P is equal to, what's p equal to? Negative 2 over negative 4 is equal to, let me move this here. Alright, so P, oh my goodness, P is equal to negative 2 divided by negative 4, which is 1/2. So that is how far the focus is going to be away from the vertex and the directrix line. Okay, so it's only going to be 1/2, so it's a little bit harder. Okay, so if we're at 1, negative 2, and we're only 1/2 away on the inside, that would put the focus right here. So what would that ordered pair be? Okay, let's see here. We're at 1/2 to the right, so 1/2, and how far down are we? We're still the same, so negative 2. So the focus is 1/2, negative 2, and now we need to go 1/2 to the right. So 1/2 to be the right, we'll be right here. Let me draw in my, try to get it as straight as possible. There's my directrix line, and now I need it's vertical, so it's x equals, and it's on the positive side, so where's that? If we're at 1 and we went right 1/2, now we're at 1.5, so you could put 3 over 2 or 1.5. I'd accept either or. So there's our directrix equation. Here is our focus. Okay, it's just a little bit harder when the vertex is different, but you got to pay attention. These numbers mean that the vertex is at a different location. Everything else is done the exact same way. All right, that's it. That's chapter 6, the 4 conic sections. Have a good night. I will see you tomorrow.